In this video, we will continue sketching polar curves by looking at r equals cosine of 2 theta. And in this case, we're going to actually skip making the table of the r and the theta values and see how we can just instead focus in on that Cartesian graph and use it to sketch the polar curve. So let's start by sketching y equals cosine 2x. Note the 2 inside is going to change the period of cosine from 2 pi to pi. So the period being pi instead of 2 pi, if we were to sketch this from pi to 2 pi, is roughly speaking, we go through 2 periods, so it looks something like this, where we would have pi over 2, 3 pi over 2, and these spots where we're crossing the horizontal axes, that would be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So let's go ahead and put this information into our polar curve. And we're going to approach this in a very methodical fashion. What we are going to do is first focus in on what's happening from theta equals 0 to pi over 4. So note this curve is oscillating between -1 and 1. So when theta is equal to 0, your r value is 1. So that places us right here. And note, when you get to theta equals pi over 4, your r value has shrunk down to being 0. So this point at the origin corresponds to r being 0 and theta being pi over 4. So I'm going to think of this as being the first portion of the polar curve I'm going to sketch. As our r value varies, or excuse me, as our theta value varies from 0 to pi over 4, the r shrinks from 1 to 0. So as we rotate around, that r value shrinks down from 1 to 0. So this corresponds to the first portion. Now let's look at what's happening between pi over 4 and pi over 2. I'm going to think of this as the second portion of the curve. So from pi over 4 to pi over 2, our r value is negative. So instead of being between pi over 4 and pi over 2, we need to go in the opposite direction. So we're going to be down here between 5 pi over 4 and 3 pi over 2. And our r value is going from 0 to -1. So as you rotate around, your r value goes from 0 to -1. So this would correspond to the second portion of the curve. And note that this point down here would correspond to, just to make sure we're all on the same page, -1 comma pi over 2. And for the rest of this graph, I'm not going to label any more points, but we're just going to continue in this very methodical fashion. So the next portion of the graph would be between pi over 2 and 3 pi over 4. So let's just call this portion 3. So from pi over 2 which is theta equals 3 pi over 4. So because our r value between pi over 2 and 3 pi over 4 is negative, we're going to be not sketching between this range, but we need to go in that opposite direction. And our r value goes from -1, and as we rotate around, it shrinks to 0. So this third portion will look something like this. So this is a very slow, very methodical fashion. But each time it should get a bit simpler. So from 3 pi over 4 to pi, we're in this range, and now our r value is positive again. So at 3 pi over 4, the r value is 1, and at pi, the r value is 1. So as we rotate around, our r value increases from 0 to 1. For the fifth portion of our curve, we're going from theta equals pi to 5 pi over 4. And our r value is positive in this range. We go from, at pi, having r equals 1, and as we increase theta to 5 pi over 4, our r value shrinks down to 0. So roughly speaking, something like this. And let's just continue on. So the sixth portion of our curve is from 5 pi over 4 to 3 pi over 2. So 5 pi over 4 to 3 pi over 2, except now our r value is negative, so we're going to be going in that opposite direction. And our r increases from 0 to 1. So that's the sixth portion of the curve. And then we'll have the seventh, and finally the eighth. So for this seventh portion of the curve, at 3 pi over 2, our r value is negative. So we go in the direction pi over 2. And as we rotate around, it's still negative, so it decreases to an r value of 1. Excuse me, r value of 0, and then the last portion here. So hopefully this illustrates kind of a step-by-step process, just dealing with one small portion of theta values at a time to sketch that corresponding polar curve. And just to represent this a bit more cleanly, the curve that we saw, we started off and we rotate it around to form what we might refer to as a four-petaled flower. And in general, it's very reasonable for us to ask you to sketch curves of this form, r equals cosine of some whole number in theta, and r equals sine of some whole number that's called m theta. So it could be cosine 2 theta, or it just as easily could be sine of 3 theta. But regardless, the approach that we've used in this example will carry over.